Now let's go to the next slide. It's about market equilibrium. Okay? So now we have a demand and a supply, and the demand and supply cut each other at this price, 3.3, with this two reduced form. So this is the demand, this is the supply. And the equilibrium, how to find the equilibrium? Or in other words, at which price the quantity demanded equals the quantity supplied at which price. So 286 minus 20p equals 88 plus 40p. Then it's 60p on the right and 198 on the left. So P equals 3.3, right? So it's easy to find the equilibrium price, and you replace 3.3 back to the demand curve or back to the supply curve, we will get 220. So when the price is set at the equilibrium level 3.3, then it will be 220. So we may find the equilibrium price and the equilibrium quantity here. But if you set the price higher than the equilibrium one, then say 3.95, then you get a supply. The quantity supply will be 246, and the quantity demanded will be 207. So we have an excess supply. This is an excess supply of 39. But if the price is set lower than the equilibrium level, then say 2.65, then the quantity supply will be 194, and the quantity demanded will be 233. There would be a excess demand of 39. When we come across of excess demand, there will be a pressure to make the price going up, right? Because more demand, more buyers want the good, and less supplier, less sellers are willing to sell. So the buyers compete with each other, saying that, I'll give you a higher price, so sell it to me. Okay? They try to compete with others. So competition makes a pressure to push the price upward. On the opposite, when the supply is higher than the demand, the quantity supplied exceeds the quantity demanded. What would happen? So the sellers compete with each other. Okay, I'll sell you at a lower price, so buy my product. Come to me, I'll sell you, right? At a low price. So there will be a pressure to make the price downward. So this is the reason why we call it equilibrium, because it's stable. There will be no extra pressure to make the price vary. Get the point? Okay? Could be simple because we have talked this in the first year. And something we're talking about comparative statistics. So what is a static? Demand, supply, price, quantity. We call this a static analysis. In Chinese, is so this kind of analysis is a static one, static analysis. But what if there's some factors happen and making, say, the supply shift outward? So when the supply shifts outward, you will see another equilibrium, and we may have a P prime and Q prime. This is another static. So we now have two statics, static 1, static number 2. So with different conditions, the original condition make it static 1, and the later on, the second condition make the equilibrium at this point. So it's static number 2. If we want to compare these two statics, we call it comparative statics. So there is a factor, some factor, say factor Z. If factor Z happens, making supply shift outward, then we are asking a kind of question: what kind of effect of the occurrence of Z to make equilibrium change? How factor Z affect the equilibrium? So we call this kind of analysis as comparative statics, because we are comparing two statics. Is that clear? Static number 1, static number 2. If we want to compare these two statics, then we call it comparative statics analysis. So some other factors other than price, other than quantity. So it can be the price of substitute, it can be the price of complement, it can be your income, or it can be your taste, your preference, or some natural disaster, some typhoon, okay, or some other things, or some, like this, can be a technology advance, right? Some new finding, or some research find a more efficient way to produce goods so that the supply can increase. Alright, so changes in a factor that affects demand, supply, or a new government policy alters the market price and quantity of a good or service. We call it comparative statics. So changes in demand and supply factors can be analyzed graphically or mathematically. And the next, we are going to tell you how to discuss a large or discrete change and small change, tiny change with calculus. So this course we will use calculus, which even, okay? Let's see first the discrete or relatively large change. Okay, this is the opposite case from this one. So supply curve number 1, supply curve number 2, and this can be happen when the price of complements goes up, right? Or when the price of substitute goes down. Or when your income, if this is a normal good for you, when your income decreases. Or when there is a natural disaster such as a typhoon attacking Taiwan, so that the supply will decrease. Then static number 1, this is the equilibrium for the condition 1. and the equilibrium, the new equilibrium for condition 2. So the price goes up and the quantity goes down. So this kind of change, the up of the increase of the price, the increase in price or the decrease in quantity is actually a result, an outcome of the change in supply. So some factor other than price and quantity may shift the supply so that the equilibrium changes. So this kind of analysis is for discrete changes or relatively large changes. And for small changes, from difference to differentiation, difference, in Chinese, difference, differentiation. So actually they are the same thing. They are the same thing, just the difference, when the difference goes infinitely small, when the difference becomes smaller, 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 and very smaller, is a tiny thing. When the difference becomes so tiny that we can use the tool of calculus, so differentiate something, like, okay, there are some useful rules for differentiation, like the product rules, okay? If you remember when you are in your first year, when you are freshman, you should have learned this in your calculus class. So the product of function f and g, when we want to differentiate the product of these two functions with respect to x, the variable x, it becomes f prime. We differentiate the first function first and keep the second constant, plus keep the first constant and differentiate the second one. So have you ever seen this rule? Yes or no? Anyone haven't seen this? Raise your hand, please. Okay, so this is the basic one for calculus. If you have never learned this, please go back to the textbook or try very hard to, because this is the basic knowledge for this course. I will not go back to review it, okay? And the quotient rule. If we want to differentiate a quotient of f of x and g of x with respect to x, then we just square the denominator and then differentiate the numerator first, denominator constant, minus numerator, denominator. The chain rule. So if y equals f of u and u equals g of x, so that y equals f of g of x is a composite function h. So how to differentiate h with respect to x? So we differentiate f with respect to u and differentiate u with respect to x. Or in this form, it can be clearer. What happened to the change in u given a change in x? So this is the effect of how x, a unit increase in x, make u change. And this is the effect of a unit of u change, how a unit of u change make the change in y. So we multiply them to make the total effect. A unit change in x, and this is the unit changed in y. Okay? So when we say dy over dx, it's just something like delta y delta x. So if this is delta x delta y, you know this will be the slope of this segment, right? Delta y over delta x. And we interpret this as a unit change in x, a unit change in x cause the change in y. So for example, if this is 10 and this is, say, 2, then this would be 5, right? Which means if delta x equals 1 unit change in x. So how many units change in y? It would be 5, right? On average. Then this version is actually quite the same of the delta version, the difference. Only we make x goes into 0, approaches 0. When delta x becomes smaller, and goes very tiny, we go to this version, the differentiation version. So actually they are the same. They are the same thing. And this one, if the curve is a straight line, so it would be perfectly the same. But if the curve looks like this, so at this point, the tangent line, the slope of the tangent line would be dy over dx. Because here, the difference or the differentiate of x is very, very tiny. Okay? So it's basically the same thing. Now, let's have a look of some examples in economics, how we economists utilize the tool of calculus to find something. Okay. Let me give you some explanations here. Now, suppose we have a demand curve D, and we make it as a function of P of Q. So you know, when you want to buy at a high quantity, you want to buy more, and only if the price goes very low, so that you are willing and able to buy this many, right? And if you do not need that many, you need just a small quantity of the good, then you may be more willing and more able to buy this. So the willingness to pay goes up. So this is a function of the demand. And actually, it's an average revenue for the firm. If this is your demand, then the reason why it is average revenue is because if the firm set the price at P prime, is a higher price, then you are willing to buy Q prime. This would be the total revenue you pay, right? The total expenditure you pay. But on the opposite, or on the other side, this would be the total revenue for the firm. You pay this much, and I, the firm, receive this much, right? This amount. So P plus Q, P times Q, P multiplied by Q is actually the total revenue. So how do we define our average revenue? it would be the total revenue divided by Q, right? So naturally, it becomes P. So P is actually the average revenue. And now we want to find the marginal revenue. What does it mean by marginal revenue? If I, the firm, want to sell one more unit to you, so I need to lower the price so that I can sell one more unit, right? Without lowering the price, I cannot sell. At most, I can sell Q prime. So if I lower the price, I can earn, or I can sell more units of the good. Only if I lower the price a little bit. But in this case, when I lower the price, I can increase the quantity sold, and the total revenue would change from this one to this one. I earned more here, but I lost a part here, right? And I'd like to know if I try very hard to sell one more unit, and how much the revenue I would get. That is, we call marginal. So we define the marginal revenue is a function of Q. It's a differentiation of total revenue. So one more unit in Q, and how large, or how the quantity, how the amount of total revenue affected. Okay? We'd like to know the effect of an unit increase in Q to make the change in total revenue. And we know that the total revenue is actually a PQ multiplied by Q. So it's a product of P of Q and Q. So we just apply the product rule. We differentiate this first, P prime, and keep Q constant, plus keep P constant, differentiate Q with Q is 1. And you will see this will be P prime of Q times Q plus this is the AR. So now we have the relationship between MR, marginal revenue, and average revenue. So the difference would be P prime times Q. What do you think this part? Is it a positive or negative part? Is the value positive or negative? Q is quantity, right? Q stands for quantity, must be positive. What about P prime? What does it mean by P prime? P prime, this is P. P prime is the slope of the curve, right? And you see the slope of the demand curve is negative. Something we call the law of demand. The law of demand describes the inverse relationship between price and quantity. So it's inversely related. So the higher price, the lower quantity, or the lower price, the higher quantity. Then P prime is a negative one. So P prime is negative because the law of demand should be satisfied. And quantity, of course, positive. So the product or the value of this part is a negative one. That is the reason why you see marginal revenue falls below the curve of average revenue. Right? Because marginal revenue is something that average revenue deduce, or average revenue minus something to get marginal revenue. So marginal revenue falls below average revenue. Is that clear? Okay? Any question here? And let's see the next one. We want to know the relationship between average cost and marginal cost. Alright, how do we define average cost? It is defined as total cost divided by the quantity sold. So this is total average, right? So everyone happy with this definition? It's fine? Okay? And what does it mean by this? If the curve of average cost looks like this, the differentiation of AC with respect to Q is actually the slope of this curve. Okay? So this term is actually the slope of AC curve. Just like yx, dy over dx is the slope of the curve on the xy plane, right? So we differentiate AC with respect to Q. It stands for the slope of the AC average cost curve. And because AC is defined by TC over Q, is a quotient of total cost and quantity. So we apply the quotient rule. Q is squared because it's in the denominator, and we differentiate TC first multiplied by Q minus keep TC constant and differentiate Q with respect to Q, which is 1. Okay? So, let me find some space. Goes up here. It equals, okay, pay attention to this. What is this? We differentiate total cost with respect to Q, which means what effect on total cost by a unit increase in Q is marginal, right? One more unit you sell, and what about the total cost change? So this is the marginal cost. And it would be the marginal cost multiplied by Q plus total cost, net minus total cost, and this is 1. And we have Q squared. But if we divided Q